So as we continue solving systems of linear equations, we're going to talk about the elimination method. We've previously talked about by graphing using substitution, and now as we go into elimination, we're going to use a variety of skills. We're going to be talking about the least common multiples. We're going to be adding like terms as we combine our linear equations. We're also going to be solving one-step equations and then doing substitution when we go back and verify when we have the value of one of our variables, and we go back and do the evaluation to find the variable of the other, or the value of the other variable. So again, it's an important skill, and it depends on the system to which method is going to be the easiest for us to use. So with the elimination method, we're going to talk about solving it, adding and subtracting using the to eliminate the variable. And from the beginning, we have always discussed that you cannot find the value of two variables, two unknowns at a time, so you have to eliminate one of those unknowns. And so as we work using these systems together, it asks us, or it says, it reads, what is the solution of the system use elimination? And that should be a period there, not a question mark. So what I'm going to do is I'm going to combine these two equations to eliminate one of my variables. And it doesn't matter which variable that you choose to eliminate, the x or the y. It just depends on the coefficients and which ones are going to be the opposites and which ones are going to be the easiest to deal with. So if you notice right here, we have 6y minus 6y. So when we go to combine this, we're going to add everything together, combine everything together going downward, combining like terms. So we are going to have 5x plus 3x is going to give me 8x. And then now what happens is my 6y and my minus 6y will cancel out. So that is going to end up giving me 0y, or just 0. We don't have to put it in there. So that is going to equal then 48 minus 32 is going to be 16. Continuing to solve for x using my inverse operations, I have x is going to be equal to 2. Now that I've found the value of x, what I can do is I can take this value and I can plug it back to either one of these equations to find out the value of y. And I'm going to go ahead and use this second equation right here just because it's a smaller number. And I'm going to take 3 times x, which we determined is 2, plus 6y equals 48. And it's going to be 6 plus 6y equals 48. Minus 6 on both sides to further isolate my variable. So I have 6y is going to be equal to 42, divide both sides by 6, and sure enough, y is going to be equal to 7. So my solution here is going to be 2, 7. And if I were to put that back in to the other equation, it would also prove to be a true statement. So solving and verifying the elimination, or using the elimination method. On this next one, we're going to go ahead and we don't have to do anything here because it looks like I have some opposites. The x, I have -3 and I have 3, so those are going to cancel out as I combine this function. So that will become 0x, and then I'm going to have -3y minus 4y is going to be -7y, and that's going to be equal to 9 plus 5 is 14. Divide both sides by -7 to isolate my variable, and y then is going to be equal to -2. Taking the value of y, plugging it back into one of our equations, it doesn't matter which equation you use, I have -3x minus 3 times -2 equals 9. -3x plus 6 equals 9. Subtracting 6 from both sides to combine like terms. And I have -3x equals 3, divide by -3, and then x is going to be -1. So my ordered pair solution is going to be -1, -2. Solving using the elimination method, we are eliminating one of our variables. Let's see here. Washing cars and trucks takes 1 hour and 30 minutes. Washing 2 cars and 5 trucks takes 190 minutes. How long does it take to wash each type of vehicle? Well, We can use whatever variables we want here. If we go ahead and say that cars is going to be C, trucks will be T, and I'll just put it over here so we don't forget. So I have the first equation, 2C plus 3T equals 130. So that's 2 cars plus 3 trucks equals 130. And the second equation is washing 2 cars and 5 trucks. So I have 2 cars, 5 trucks is going to equal 190. Okay, now, and I'm sure a lot of you could turn around and tell me the answer without doing any math, but let's go ahead and do this. In order to combine these, if I just combine these two equations like we did the last ones, nothing's going to be eliminated because I don't have any coefficients that are opposite. So what I can do is I can take one of these and I can go ahead and multiply it by a -1. And what that will do is, as long as I multiply, the whole thing by the same value, I haven't changed it. What I do to one side of the equation, I must do to the other. So if I go ahead and multiply 2c by -1, I have -2c. 5t times -1 is going to be minus 5t. And that is going to be equal to a -190 when I multiply 190 times -1. And again, that's 1 times -1. Now, what I've done is I've just changed that. And I'm going to go ahead and bring this equation down here just to where it's a little bit easier to see. And that is going to be equal to, now I can do some combinations because my 2c minus 2c is going to cancel out. And then this is going to carry down. I'm going to have -5t plus 3t is going to be -2t, and that is going to be equal to -190 plus 130, so it's going to be -60. Go ahead and divide both sides by the coefficient over here, and t is going to be equal to 30. So it looks like in context, trucks take 30 minutes to wash. Now, if we know that, what we can do is we can take that 30 minutes and we can plug it back into either one of these equations. So I know that I have 2 cars plus 3 trucks, which we said that trucks take 30 minutes, equals 130. So I have 2 cars plus 90 equals 130. Go ahead and subtract 90 from both sides to combine like terms. And there we have 2c is equal to 40 minutes, or divide both sides by the coefficient, and a car is going to take me 20 minutes. So my solution is going to be 20 minutes for a car and 30 minutes for a truck. And there you go. We're using some real-world examples there to go ahead and use the elimination method. Now, as the elimination method gets more difficult, it's really going to become what are you better at using and what works for you. So here I have, let's see here, this equation, the system that works together. It says, what is the solution to the system? Use elimination method again. Well, I don't have any exact opposites, but I can see here I have a -2y and a positive 6y. So what I can do is I can turn around and say, hey, let me take this equation right here, the top one, and I am going to go ahead and multiply it times 3. And as long as what I do to one side of the equation, I do to the other. I haven't changed its value. I've just changed its appearance because I'm making an equivalent equation. So when I do that, that becomes -5x times 3, which is going to give me a -15x. A -2y times 3 is going to give me a -6y. And that is going to be equal to 6 times 3, which is 18. So I have created a new equivalent expression or equation. Now I can go ahead and do some combinations because right here my y's are going to cancel out. 6y minus 6y is going to give me that 0y, which is eliminating a variable. So now as I keep going, it looks like -15x plus 3x is going to give me a -12x. That is going to be equal to 6 plus 18, which is 24. And I'm going to go ahead and divide by the coefficient. divide both sides by the coefficient, and x is going to yield -2. And again, in order to find out what the heck y is equal to, we're going to go ahead and plug x back into one of the original equations. So I'm going to take 3 times -2 plus 6y is equal to 6. -6 plus 6y is equal to 6. Go ahead and add 6 to both sides to isolate my variable. And that is going to be 6y is equal to 12. Divide both sides by its coefficient. To isolate the variable, y is going to be equal to 2. Now, if I know that y is equal to 2, again, I can bring that up here, plug it into one of my original equations. And in doing so, I don't need to plug it in the original equation. I just did that. So I'm sorry. I have x is equal to -2, y is equal to 2, or ordered pair -2, 2. There we have it. Okay. So using the elimination method and manipulating the equation to where we get what we need. Continuing here, it says solve a system by multiplying both equations. Okay, sometimes it can't be done with just one multiplication. Sometimes you may have to do 2. And as you get into higher levels math, you may just multiply by a fraction. But let's just go ahead and see what we can do. And multiplying both equations, what we're looking for is I do have some opposites here. My y variable, I have a positive and I have a negative, so those are my opposites, and I just need to figure out what's the least common multiple of 2 and 3 that I could, come up with. I think that's going to be 6. So if I were to take this top equation, and in order to get 3y equal to 6y, I would need to multiply it times 2. And that is going to yield 2 times 4x is going to be 8x, plus 2 times 3y is going to be 6y, and that's going to be equal to -19 times 2, which is going to be a -38. Now, I'm again trying to get to a 6y because I had the opposites, so I am going to go ahead and multiply the second equation by 3, because that will give me that least common multiple of 6. So 3 times 3x is going to give me a 9x. 3 times -2y is going to give me a -6y, and that is going to be equal to -10 times 3, which is -30. Now, I can go ahead and combine these, and I'm going to be able to eliminate some stuff. So, in combining them, 6 minus 6 is going to give me 0, and then 8x plus 9x is going to give me 17x, and that is going to be equal to 38 minus 38 minus 30 is going to be a -68. I hope I've been doing the math right all along here. It just seems a little bit crazy. But let's see, what can I do? If I divide by 17, because that's my coefficient, I'm just going to keep going. Trust in what I'm doing. So divide by the coefficient, and then it looks like x is going to be equal to -4. So if x is -4, how am I going to find out what the heck y is? Well, again, I'm going to plug it back into one of these original equations. So I'm going to have 3 times -4 minus 2y is equal to -10. So I have -12 minus 2y is equal to -10. Go ahead and add 12 to both sides. -2y is equal to 2, divide by -2, and then y is going to be equal to -1. So there you go. My ordered pair solution will be -4, -1. So sometimes you may have to do, finding that least common multiple, you may have to somehow manipulate both equations. And then find the number of solutions. Well, I think the number of solutions we said before were going to be, we could have one solution is when we have an intersection point. We could have no solutions when we have parallel lines, or we can have infinite number of solutions when we have the same equation. So let's look. How many solutions does this system have? Well, right here, in order to do any kind of elimination, I'm going to have to do something to one of these equations. And here, if I just look for an opposite, I can go ahead and multiply that by -2, and that will give me the opposite of 2x. I'll have -2x. So let me go ahead and multiply that times -2, and that's going to give me a -2x minus 6y is going to be equal to -18. And then I'm going to bring this first equation down and rewrite it. So I'm going to have 2x plus 6y is going to be equal to 18. Oh, goodness gracious. Now what happens when I go to solve this? When I go to combine my two lines, it turns out that I'm going to have 0 on one side because my 2x minus 2x is 0. 6y minus 6y is 0. And that is going to be equal to -18 plus 18, which is 0. And 0 equal to 0 is an identity, and what we have there is, like I say, is a true statement. If it's a true statement, then we are going to have an infinite many solutions. So that's infinite. Those two equations are identical. Infinite many solutions. And another thing that you could have done is, never mind. You guys are doing good, who cares? But we could have taken this second equation and we could have multiplied it by 2, and we would have seen that these two equations would have been identical then, because that would have given me 2x plus 6y equals 18. So there's different ways to be thinking about these numbers and how you can manipulate them. Okay, so as we look here, this equation looks like my x and my y variables are not opposite, so I need to go ahead and make one of them opposite. So in order to do that, I can go ahead and just multiply times -1. So in doing so, this second line becomes 2x minus 5y is going to be equal to -12. And with that, let me go ahead and rewrite this and bring it down. So it's a little bit closer and easier to work with. And then when I go ahead and combine my equations, I am going to have 0 plus 0 equals -5, or 0 equals -5. And I think we're looking here as 0 equals -5 is not going to be a true statement. And we need to say, okay, well, what do we have here? So if we have 0 equals -5, that's not a true statement, so we're looking at no solution. No solution. So there are different ways. We're still doing the same overall information, and we're still using the same vocabulary, the same principles, and math operations. It's just a matter of being able to look at them and applying a different method in which to come up with a solution.